So is that frog dead now?
Well, she had said it's brain dead. She had killed a brain before she let anybody in there. And then she was just explaining that the brain was dead, and then there was when she destroyed all of the spinal cord nerves, because all of the movement that you saw was spinal reflexes, and so she destroyed the spinal cord so that it wouldn't have to. But everything else is still going, and there's still the ATP being used up and all of that stuff.
This your arm? Then I got home. Are we supposed to the distance or the time?
Yeah. Well, you need the distance in order to find it.
So this is he's here. That's awesome. I love it.
Like minions.
Jordan hair is pretty thin. Down the bed. Yeah.
No, I'm good.
I can't figure it out.
Tape it.
I know how to take pictures, but I don't know how to record.
So Amanda, if I have
We're supposed to tell you 25.
No, record straight.
Oh.
Yeah.
Do you think I messed it up?
well, she does a lot of things. She does electrical current.
I just sent off that picture. My electrical current is so great, it just has fingers.
Thank you.
Oh.
We did two bigger and smaller, and I didn't feel as bad, and they were ours were huge. That's a big problem.
So basically, I counted my interval from Q to Q, and there's 4.
Okay.
And so I took 4 divided by 25.
Okay, so then for PQ, here's P. Okay. So 1, 2, 3, 4. So, and then to divide that by 5. Yeah.
Do you count from the very end of
We're comparing our waves, our QRS waves, and they're virtually the same. One guy's a smoker, the other guy's an athlete. But then comparing it to the girls, you guys have a higher spike in QRS.
Even that's not consistent. Ours over there.
That's cool.
We did one over there and one over there.
Okay, so I'm confused. On the PQ, we've got 4 lines,
How's yours?
And maybe it's
and you divide that by 25.
you guys weren't holding your, you were just setting your hands on your lap. That's why I was holding mine up. They're blocked. That's why. So that's why I was holding my hands up.
Maybe females just have a better.
My hands just don't like naturally rest on my lap. Weird. They like turn it.
Is B like
Like, I don't know what's wrong with my arms. Like, I can't.
Oh, I can stop there.
But he's the same as B.
That will be all of that.
Your B wave is
I do mine. See if that's like next
Oh,
one.
I know.
I've changed like I can see it already dropping like in the middle of it.
Do you mind reading my
See the heart? Here, let me increase the magnification a little bit. Thread out of the way here. zoom in, but it doesn't work the way it doesn't focus.
Hit the orange button on the side, and that should focus it.
That's almost going worse. Oh, there we go.
You get the heart?
There we go. Okay, so frog hearts have one ventricle and 2 atria. So I've opened up, so they're pumping, receiving from lungs and from body, but pumping at the same time to both. So obviously the same pressure is going to be exerted with both of these. And I'm going to open up the pericardial sac a little bit more. Let me put it down here and give myself a little bit more room on this side.
She just sniffing the frog.
I want to just cut this part off.
Bad for that frog.
Doesn't feel anything.
You're the best commentator.
Huh?
Okay, so here we have the ventricle, and up here would be the 2 atria. And then I'm flipping the probe around the pericardial cavity. Okay,
So that would be in between the visceral and the parietal?
right, so I'm touching the visceral right now.
Okay, yeah.
Okay, and the parietal would be up here.
Okay.
So I don't want to, I want to try dripping some medication on it now. We had a transducer, and that's why I have the fish hook here, is it's possible to hook the tip of the heart onto the hook and hold it up like this, and then with the transducer you would see the ventricular contraction and the smaller atrial contraction and so on. But I don't want to lose that before I drip some of our medications on it. So what did I do with that tray? Here, so the 2 medications that we have are, whoa, are epinephrine and acetylcholine. And I thought I had a larger dropper here. And so I'm just going to put some normal saline, Ringer's solution, on the frog heart just because the frogs breathe through their skin. And so just want to keep this moist. And then when we're done, we can actually remove the heart from the frog itself, and you will see that it will continue to be outside of the frog heart, provided we don't stress it too much in its location. So it's already going pretty slow. So let's put some of the adrenaline in. Adrenaline is epinephrine, which is the adrenal gland form of norepinephrine. I'm going to dilute it first, and then we'll see what concentration it requires to actually be effective.
Is that DI water?
No, it's Frog Ringers, which is a specific association of potassium and chloride and magnesium and other ions. Not what we have in our body, but what frogs have in their body.
Okay.
So that's diluted, and we'll see if it has, not mathematically, but we'll see what effect it has. Anybody time it? Why don't we take a heartbeat for, anybody have a second hand, or look up at the clock and take a heartbeat for, let's do a full minute, in case we don't have much of a change at first. Noel, why don't you just count for a minute? And tell me when to start, and I'll count, and you look at the clock,
Okay.
okay?
4.
Start.
That's like
stressed him out.
So bad. We almost made it to a minute.
There you go.
Got that scene from Trout Thunder in my head. Survive.
You want to do it? Stronger contraction here.
He's doing it like super slow. It's swimming down. The ringer is too cold.
4.
So it's going a little bit faster than it was prior.
Sure about that?
I don't want to put too much on
It was
it.
like not moving.
Yeah, it's not 6,
No.
7.
All right, so what's happening internally? This is epinephrine, so both two different types of cells are being affected. The pacemaker cells, we're affecting the bunny channels and the calcium channels to increase the rate at which they fire. And then if we had it on a transducer, we would also see that there's a greater force created by the ventricles because we're opening calcium channels in the ventricles, adding additional calcium and adding additional actin and myosin. Okay, I'm going to put just a little bit of this higher drop. Don't want to. So it is cold.
2.
Okay.
So does the tip of the ventricle seem to be lifting up higher?
Stronger.
So you're seeing a stronger force of contraction there. So I think that first slowdown is the temperature effect.
Because it's exposed to the,
It's a cold solution, so that's going to decrease ion flow there. So for a while, you can see it's a much stronger force of contraction. Okay, then I'll flush it. Actually, before I do that, I'm going to flush it, and then I have, let's see if we can, well, it's a little more difficult to see without a transducer. But what I'm trying to simulate is an atrioventricular block. So an atrioventricular block is a interference, if you recall, with the connection between the AV node, not the SA node to AV node, but AV node to the ventricular apex. And therefore, it can take longer or completely interfere with the transmission of the current, and you will have a P wave, but you won't have a QRS wave. Or you may have two P waves before you get a QRS wave. All right? That would be a complete block. So it might be for a long time, you'd have a P wave, and then wait a really long time, and then you would have a QRS, or you might have 2 or 3 P waves before you got a QRS. Obviously, you would need to have a QRS, or you would not have heart movement. Okay? So what I'm going to do is split this thread up into spine and in between the atria and ventricle. Go ahead and try, which this is all experimental, to do it without holding it up on the fish hook. So I don't want to poke a hole. It would be quite cardiac tamponade, as the cardiac cavity isn't, the pericardial cavity is already open. But it would certainly, every time the heart beat, it would leak blood. I'm not sure if you can actually see atrial contraction right here. Okay, so now you can see atrial contract, ventral contract. So I'm going to tie the string up just a bit.
And then 5.
practicing a one-to-one, aren't we? I want to tie it off completely. This thread's a little bit wide. They'll let me remove the thread, and now I'm going to try the push-up because that will give me better access.
This is your P. You have L and buckle. And then you can do your T to your P.
Now, can you imagine trying to do open heart surgery on an infant? Infant hearts are about the size of a walnut, newborns. You can imagine the type of microsurgery. Now you can see the ventricular, the atrial at the bottom here. Okay. I'm still seeing one and one. What do you guys think? Atrial contraction is the ventricular contraction. Oh, we got it that hard.
Physics is awesome. Yeah, I guess you can never go to 0 Kelvin. Negative 3,000 Kelvin.
But tied off is off practically off.
Is it coaching?
So it doesn't
But
scale.
loosen that out, and I'm going to try to do it without it completely overlapping.
Can't go to 0, I should go to negative.
Just put more fingers.
Professor, it's,
The next thing I'm going to
Professor,
do,
it's not on the.
the next thing I'm going to do is just go ahead and cut it out of the heart and place it in a beaker to show how it continues. I don't want to do too much damage to it before it. It really did show a disconnect on the AV block. Let me get a, I want to kill it completely.
Can you just send that video or something?
Not yet, I'm going to.
Do you send it to?
My dad?
You send like all the pictures?
Oh yeah. Last time I sent him a picture of the heart dissection, and he's all sweet and sent me back a picture of his BLT sandwich he was eating when I sent the picture to him.
Did you keep eating it?
Of course.
As soon as my EKG or ECG or whatever.
All right, so anybody want to take another look at it before I cut it out of the heart? I mean, out of the frog body, then I'm going to put it in the Springer solution here.
She's playing God of Frogs.
Just a flat. So if this was on a transducer and that thread was attached to a recorder, every time the heart's pulled down, it would cause the needle to deflect. And the amount that that needle was deflected would be shown in the force of contraction. So what you'll see on a recorder is you'll see
Do you mind not standing right there?
a little bit of atrial contraction and then ventricular contraction. And then atrial contraction and ventricular contraction. Okay, so that's what you would have in, if we had a transducer on that. All right, so I'm gonna. So you gonna put this in there?
Yeah.
Okay, it's not all the way into the chamber, otherwise every time it contracted, it would leave. Now, it may be in the chamber, it's just blocking. So if I, when I take the needle out, then there would be blood obviously leaking from the myocardial vessel.
Wait, too short.
But we have to see how much actually is.
So it's also important.
It's okay, I just.
How much,
Sorry. How much do you need?
Amanda! Stop giving me your hair. Taunting me.
How much do we need to put on our line? Just a chunk? Probably what you counted.
Oh, that's such big strong hair.
Oh, thank you, thank you.
See how much larger the
Mine's like
atrium
half
is?
the size.
Because the ventricle is.
Yeah, my hair's pretty thin too. I tried taking biotin supplements to see if it would. I haven't been taking them long enough. It's working out.
Let me hold that up to one of mine.
I wish I had my hair.
Then,
Wow.
That might not be my hair. I don't think
What color?
it's really dark.
It's a brown color.
I have red hairs that are
See the atrium contracting.
That's the difference between
The ventricles really aren't yet, so let me add epinephrine to that. It's because I still have the thread around it. Okay, so. Let me just add some epinephrine to that. If we look on top, you can see the atrial. Let me just do this.
Take it back.
See the, even though
Oh, you can see it.
the string is still tied between the atrium and ventricles, you can still see. So there's obviously no nerve connection. So what you're seeing are the algorithmic cells continuing to depolarize and fire. And they will continue to do that as long as there is ATP available to replace the ions. Once it does an action potential, calcium ions have to be pumped out. Calcium ions have to be pumped out, and potassium has to be returned so that it can fire again. As long as there's mitochondria and ATP available for that, you'll continue to see this occur. The colder the solution, the longer it would last, because it would be pumping at a slower rate with a lower oxygen
You never had short hair, so.
from the muscle tissue itself. I was trying to demonstrate an atrioventricular block
Except for when I had
by blocking at the AV node or from atria to ventricular bundle. So, or else a decrease in rate, because if I block above the AV node, that would still fire, but about half to a third the rate of the SA node.
They're saying I should like.
But I didn't see that disconnect.
Oh, she made a
So the afternoon lab, I'll try it with
I'm
red.
not saying to shave it, but do something different. 25 is when I decided to ditch my glasses.
It's still moving the thread.
decided to ditch your comb over and go all natural.
I never had a comb over.
I've seen
never
doctors
did.
for 40 years.
I can show you a picture of a few years ago when I had longer hair. I'm sure
He
you've seen
decided
it.
to grow it on his chin instead of his head.
It's not true. I always had a beard.
That's what I'll do.
Just like bring it over.
Because that's a buildup of fluid within the pericardial cavity. And if the pericardial